submarine is far more than a ship. It is a sophisticated, self-contained survival system built to conquer the crushing depths of the ocean. To master the water, a submarine must control its buoyancy. It uses ballast tanks to manipulate its weight relative to the surrounding sea. When the crew needs to dive, they open valves to flood these tanks with seawater. The increased weight causes the vessel to sink beneath the waves. To return to the surface, compressed air is blasted into the tanks, forcing the water out and making the submarine light enough to rise again. But simply sinking or rising is not enough. The vessel needs precise depth control, which is achieved through the use of external hydroplanes. These hydroplanes function much like the control surfaces on an airplane, steering the submarine as it glides through the underwater currents. Inside the hull, the crew also manages trim tanks. By shifting water between the front and rear, they keep the vessel perfectly balanced and level. As the submarine descends, it faces a relentless enemy: water pressure. Every 10 meters of depth adds an immense amount of weight on the hull. To protect the crew and equipment, the submarine is built around a pressure hull. This inner shell is typically cylindrical to distribute force evenly. While the outer hull is streamlined for speed, the inner pressure hull is the true shield that prevents the ocean from crushing the vessel. Because light and radar cannot travel far underwater, submarines rely on sound. This technology, known as sonar, is their primary way to sense the world. Active sonar sends out sharp pulses of sound to map the surroundings, though this also risks revealing the submarine's own position to others. Passive sonar is the silent alternative. It simply listens for the faint signatures of propellers, engines, or pumps from distant vessels. In the deep, silence is a submarine's greatest defense. Sound travels exceptionally well underwater, making any noise a potential beacon for detection. Engineers go to great lengths to minimize noise. Every pump, pipe, and engine is carefully isolated to prevent vibrations from reaching the outer hull. Even the propeller is a critical point of failure. It is designed to prevent cavitation, where collapsing bubbles create a distinct, detectable sound. To power these systems, conventional submarines rely on diesel engines to charge massive batteries, allowing for quiet electric operation while submerged. Nuclear submarines offer a different advantage. By using a nuclear reactor to create steam, they can stay underwater for months without surfacing. Inside the vessel, the crew lives in a sealed environment. Advanced life support systems are required to keep the air breathable and safe. These systems constantly monitor the atmosphere, providing fresh oxygen while scrubbing away the carbon dioxide exhaled by the crew. Humidity and temperature are also strictly controlled, ensuring the interior remains a stable environment despite the cold ocean outside. Fresh water is another necessity. Submarines use high-tech desalination systems to turn seawater into drinkable water for the crew. Communication is a difficult challenge, as radio waves struggle to penetrate deep water, often forcing the sub to rise toward the surface. For navigation, the crew relies on inertial systems. Using gyroscopes and accelerometers, they track their position without needing external GPS signals. Modern vessels have replaced the classic periscope with an optronic mast. This digital system uses cameras and sensors to see above the surface. This allows the crew to observe the world above while keeping the submarine safely hidden deep beneath the waves. In a dire emergency, the crew can initiate an emergency blow. This rapidly forces all water out of the ballast tanks to achieve maximum buoyancy. The submarine then surges upward, rising to the surface as quickly as possible to escape a dangerous situation.